All right, 6.2 is solving systems by substitution. With substitution, you guys have, last class, you did it by graphing. So we had this graph, and where the two lines crossed, that ordered pair was your solution to your system. What you're going to do today is we're going to do it algebraically. So no more graphing, no more of that nonsense if it's nonsense to you. Because sometimes you have fractions and decimals and things that are not necessarily super easy to see on a graph. So let's go look at an example of what one of those would be. So I've got this example right here, and I'm going to say y equals 3x and y equals x minus 2. And before we actually solve this, I'm going to write out the steps as we go. So I'm going to say step 1. Pick an equation, either one, it doesn't matter, and solve for a variable. This variable that you solve it for can be x or y in this case. It doesn't matter which variable you choose to solve for. Let's look at, we'll pick equation 1 this time. It's already solved for y, so I have y equals 3x, and that's where I'm going to start at. Step 2 then says plug equation, the one you picked, plug the equation you picked into the other, or into the second equation. So plug equation 1 into equation 2. So we're going to take it into this equation right here. I've got y here, and y is equal to 3x down here. So here is what y equals. So now I've got 3x equals x minus 2. All I did is I took this 3x and I substituted it in for y in the second equation. So we're left with 3x equals x minus 2. Step 3 says solve new equation for the variable. So in this case, I'm going to solve this for x. So let's get the x's on one side. We'll subtract x from both sides. 3 minus 1 is 2x equals negative 2. And then divide by 2. So x equals negative 1. That's one answer. But remember, with a system of equations, I'm looking for an ordered pair. So I've got to find a y. We need two numbers always. So now plug value into an equation. And when I say into an equation, I mean one of the first two equations. It does not matter which equation you choose. If I started with y equals 3x, and then I had y equals x minus 2, I'm going to plug it into one of these two equations. It doesn't matter. We found in the last slide that x equaled negative 1. So we're going to plug it into an equation. We'll do the top equation is where we'll plug it into. So y equals 3x, or 3 times negative 1. Just substituted that in for the x, and that equals negative 3. So y is negative 3, and remember, it has to be in an ordered pair. So your fifth step, number 5, write answer as ordered pair. So my answer was always is an x comma y. So my x value is -1, and my y we found to be -3. And that is the solution to your system without having to graph it. One can say, woo, no graphs. Happy face. Alright, we're going to do another one because this equation, when we started it, y was already solved for. So we're going to look at what happens when I don't have y already solved in my equation. And it could be x that we're solving. So let's example. I'm going to say x plus 2y equals -1. X minus y equals 5. And I will say a helpful hint is to pick an equation with the variable that is alone. I know I'm writing this sideways on purpose so that I've got a little bit more room. If you look at, and I'm going to put it in orange, if you look at this x, and this y, there is no number sitting in front of it. The number is 1. So that's what I mean by picking an equation with a variable that's alone, because these are easy to solve for. All you have to do is move something over. So what I'm going to do is I'm actually going to solve it, the bottom one for y. And so we're going to solve this equation for y. So we'll start with x minus y equals 5. And we're going to subtract the x from both sides. So I have -y equals 5 minus x. Remember, y has to be completely and totally by itself. I've got this negative here, so we'll divide everything by -1. So my new equation is y equals -5 plus x. And I'm actually going to rewrite this system on the next page so we can do the solving piece of it. I've got x plus 2y equals -1, and y equals -5 plus x. Since I solved the bottom equation, I'm going to plug it in for y up here. So no matter wherever I see a y, I'm going to replace it with x minus 5 into that y. So everything that's underlined is going to get replaced because y and -5 plus x hold the exact same weight. It's like they're like twins, where they can do the exact same thing as the other one, even though that's not always a good analogy. Anyways, they hold the same value. Like y could be a dollar bill, and this stuff over here could be 4 quarters. They hold the same value. So I'm going to substitute it in. So x plus 2 times, and I'm plugging this in, -5 plus x equals -1. So now our next step said we need to solve for whatever variable we have, because what you're doing is you're eliminating a variable. Up here we had an x and a y. Now we've just got x's that we're trying to get rid of. So now x equals your distributive property. 2 times -5 is -10, plus 2x equals -1. Make sure you put your like terms together. So 3x minus 10 equals -1. I'm going to add that 10 to the other side. So I've got 3x equals 9. And I'm running out of room on this page, but I want it all together. If I divide both sides by 3, I have x equals 3. And that's half our answer. X equals 3 up here. And remember, after I find x, I'm going to plug it back into one of my 2 original equations. So I'm going to go back to my original system, x plus 2y equals -1. And x minus y equals 5. At this point, once you have x, it does not matter which equation you plug it back into. We're going to plug it into the bottom one. partially because there is nothing here, so my solving's a little bit more simplistic. So I have 3 minus y equals 5. Let's subtract the 3. Negative y equals 2. Divide your negative 1. Y equals negative 2. And remember, your answer must be in an ordered pair or it's not correct. So 3 comma negative 2. And that is your solution. We'll put a little squiggly happy around it because we are successful. Alright, we're going to do one more example. We need to solve for x. That's what we're going to do next. So our final example tonight is going to be 2x plus y equals negative 4, or x plus y equals negative 7. Now the fun thing about these types of systems is it doesn't matter what you solve for. If you solve for y, you'll get the same answer as if you solve for x. But remember, always pick the variables that have nothing in front of it. So that'll help you figure out what equation you want to start with. So I'm going to pick equation 2 to start, and I'm going to solve it for this value of x. So x plus y equals negative 7. If I'm solving it for x, I'm just going to subtract the y to the other side, exactly like if you were solving for y. So x equals negative y minus 7. And remember, I'm going to plug it in to the opposite equation of what what I started with. So it's, if I solve for 2, I'm going to plug it into number 1. And again, it holds the same weight. So wherever I see an x, I'm going to replace it with negative y plus 7. So I've now got 2x plus y equals negative 4. And I have x equals negative y minus 7. So I've got an x here, and all of this is the same thing as x. What I'm underlining in black, they are all the exact same. So I'm going to plug it in to my original equation, or to the opposite equation. 2 times, wherever I see an x, I'm going to replace it with negative y plus, or minus 7, excuse me. I think I misspoke that earlier too. Plus y equals negative 4. Distributive property is your best friend this lesson. So negative 2y minus 14 plus y equals 4. Put those like terms together. So I've got negative 1y minus 14 equals 4. If I add that 14 to the other side, I now have negative y equals, add 14, that should be negative 4, sorry I forgot my negative sign, should be 10, divide by negative 1, y equals negative 10. So I have half my equation. Remember, I'm on a mission to find x. So today you're doing a lot of substitution and a lot of simplification. There is a lot of room for error, so be super, super careful as you're plugging things back in. Remember, once you find one, you're going to go back to your system that you started with. And we started with 2x plus y equals negative 4. X plus y equals negative 7. And I just discovered that y equaled negative 10. Once you find one value, it does not matter which one you plug it back into to get x. So I am going to say we're going to plug it into the bottom one because there's a little bit less work involved in the bottom one. If you notice this 2 up here, you have to multiply. Down here, you're not going to have to do that. So you'll have x plus y equals negative 7. We're going to replace the y with negative 10 equals negative 7. Add 10 to both sides, and x then equals negative 7 plus 10 is 3. So now your solution to your system is 3, negative 10. Please, guys, feel free to rewind and rewatch and write those steps down that I listed out at the beginning in that first example, and that'll make this process easier for you. It's a little bit more involved than what you guys have done, but you are more than capable of doing it, so that's what you are going to keep working on, and we'll work some more on it in class tomorrow.